Okay, now we will talk about another concept that is illustrated in the video I posted for you yesterday, which is inversion. What is the idea of inversion? The idea of inversion is to create a different type of motion, if possible, by just changing the grounding of a link in the kinematic chain. So, for example, if you take the example of the 4-bar linkages, you can create 4 inversions by just changing the position of the ground. Okay, and we will see that to define what we call distinct inversions, they should produce different types of motions. So sometimes we can make inversions, but they will not lead to variation in the type of motion. This is why we differentiate what is called distinct inversions. Distinct inversions will allow us to create a new type of motion. To illustrate this, I will go over one example first, which is the system used in internal combustion engines. Okay, you know that the concept of internal combustion engines is to transform the translation of a piston to rotation of your crank. So in this case, the piston should be moving in translation relative to the cylinder. Okay, so to do this, to create this effect, I have a 4 linkage mechanism, but I have a 1 slider joint here to cause the sliding of piston, and I have other 3 revolute joints connecting the piston to the rod, and other joints to connect the rod to the crank, and a joint to connect the crank to the ground. Okay, so what will happen here, if I use an appropriate inversion, I can create the desired motion. I should ask myself, what is the type of motion required in an internal combustion engine? It's the translation of the piston. Okay, so I want my piston to translate. This is why I should fix link 1. Okay, so link 1 should not be this should be my reference, and the other part will move relative to link 1. In this way, when I fix 1, then 1 will constitute what? This is the body of the cylinder. Okay, so it's attached to the cylinder, it's linked to the cylinder, and my piston will be able to translate relative to the cylinder. And then what will happen, as my piston translates through the system of rod crank, I can transfer the translational motion to rotational motion. Okay, now how we can relate these, yani how we can determine the output angular velocity function of the displacement of the piston v, velocity, linear velocity v. We'll see this when we do the analysis of velocity, acceleration, and position diagrams. Okay, now just we need to understand the operation of the mechanism, and after we'll relate the output motion to the input motion. So in this case, for the first inversion, which consists on grounding link 1, the type of motion obtained is translation of my block. Okay, now let us explore another type of inversion by now fixing link 2 to the ground. So we consider that 2 is grounded. Then what will change? If we do this, let us see what will happen. So if you ground this link, what will change then? You will have this point is fixed, okay, and this point also is fixed. Now, what will happen is the following. You have this point here, the center of your block, okay, will undergo a rotation about this point, because this point is fixed. Okay, since this point is fixed, this will create for your coupler part, if you want, this will no, it's not here a coupler anymore, because it was a coupler in the first situation, because we said that a coupler has no fixed point. Okay, now since you fixed the link 2, then this link 3 is not a coupler anymore. It will do the a rotational effect, pure rotation about this point. So the center of your block will then do rotational motion. Okay. Now, until now, you have that the center of block is doing rotation, but I know also that this block can do translation relative to link 1. So what will happen is that my block will have what we call complex motion, because you are translating on a rod, okay, and this rod is rotating about this point here. So you are relative to this rod, you are doing translation, but this rod is rotating around a fixed point here. So this will give your block a combination of translation and rotational motion, which we call general plane motion or complex motion. So in this case, we say that we were able to create a new output motion by doing inversion 2. So this is a distinct inversion compared to the first one. Now, the third possibility here is to fix now this link. So if we fix this link, let us see what will happen. If we fix this link, what will do the block? What will be the only possible motion of the block? So look, what will happen then, the center of your block is fixed. It cannot move anymore. So whenever you have in a rigid body a point that is fixed, that cannot move, then your body, your block will just rotate about this point. Okay? So in this case, this inversion will lead to pure rotation of the block. It's true that it will slide relative to 1, okay, because link 1 can go back and forth. So here link 1 will go back and forth, okay, so if you are standing here, you will see relative to link 1, the color or the block is translating. But if you are an external observer, if you are in the absolute frame, then you will see that this block will do a rotation. Okay, so this block will just do a rotation about a fixed point relative to an absolute frame, while relative to the frame of link 1, a frame fixed to link 1, it will translate. Okay, but here, since we are interested in the absolute motion, the absolute motion will be just pure rotation. Okay, any question on this? Okay, so here we have seen that until now the 3 inversions will allow us to get distinct type of motion. So there are 3 distinct inversions. Now, another possible inversion is to fix the block, and of course this is different than all types of motion we have seen before, because when I fix the block will be stationary. It will not have any motion. Okay, so if I'm staying here, if I'm fixed to the ground, I will see that this block is not moving. Okay, so then I say I was able to create a stationary case when I considered that link 4 is grounded. So I was able then to create 4 types of motion for my block. The first one is translation. The second one is general motion. The third one is pure rotation. The fourth one is a fixed case. Okay, so then I can say that I have 4 distinct inversions because they allowed me to create 4 different types of motion. Now, you will tell me, what is the purpose of getting this fixed? This will allow you to create a certain output for other links. Okay, so we'll see that this mechanism is used in hand operated well pump mechanism. The idea of this system will be to move a certain object back and forth relative to a fixed one. Okay, and in reality it will be in the reverse position. So the piston, this block will be down, and the links 2, 3, 4 will be up in the upward position. I will post a video for you and I will explain it in more detail in next session as an example, to see how this system can be implemented for hand operated well pump mechanisms. Okay, now so we have seen how we can create several inversions by just changing the link which is attached to ground. Okay. Now, if we move to the 4-bar linkage mechanism that we are familiar with, okay, here we'll see also what are the different types of inversions that can be produced with this mechanism. Okay, the idea here is to always the number of inversions will be just equal to the number of links, because whenever you ground a new link, you consider that this is a new inversion. Okay, so if I take the example of 4-bar linkage system, and to remind you, when I say that it's a Grashov 4-bar linkage system, whenever you see the word Grashov, this means that it can undergo at least one of one of my links can undergo complete rotation. Okay, I might have, as we'll see together, we might have just one link doing complete rotation. We can have several links doing complete rotation. Okay, but at least we should have one link in the mechanism able to do complete rotation, to name it as Grashov system. Okay, now how we can create the inversions here? It's very simple. We have 4-bar linkage. Okay, the first inversion can be created by grounding this link. So if we say this is link 1, this is link 2, this is link 3, this is link 4. Okay, the first inversion is by grounding link number 1. And now the second inversion is by grounding another link. So for example, if I ground link 2, I obtain a second inversion. If I ground link 3, I will obtain a third inversion. If I ground link 4, I will obtain my fourth inversion. Now, if we want to know if they are producing a different outputs or not, okay, we should study for each case what will be the output motion. Okay, so this is what we will do in detail by calculation, by introducing the Grashov condition. The video I posted for you will explain for you this condition and will show you that if I ground different links, I can obtain different types of motion. And for example, if you look at the following case, the shortest link, your shortest link is grounded, is not ground, yani is grounded, but is linked to the ground. Okay, sometimes the shortest link can be the ground itself. Yani this will create a variation, because here, for example, if we take the comparison of these two cases, in this case I have, let's say, the shortest link linked to the ground. Also here the shortest link is linked to the ground. This is why I expect that the output motion will be similar for these two cases. This is why we say that it's true that we have 4 inversions, but they are not distinct all. Okay, so here these are called 2 non-distinct inversions, because they will produce the same output motion, since in both cases, okay, the shortest link was related to the ground. So if you observe, we can see that and will demonstrate by the Grashov condition and by the different variation, that when I link the shortest link to the ground, then the coupler, my output link will have intermittent motion. It will be a rocker. Okay, so when can I obtain a rocker output of motion? When I link the shortest link to ground, and these 2 inversions satisfy the condition that the shortest link is linked to the ground. This is why I say that these 2 strategies, or these 2 inversions, are non-distinct inversions. Okay, because both will lead to oscillatory motion of my output, which is the rocker. Okay, so here I can create a rocker motion. I have my crank is able to do full rotation. Okay, now if I look at the other types of inversions created, when the third type is when the shortest link is grounded. We can, if we simulate this, and you can see in the video I posted for you the simulation of this case. If you simulate this case, you will see that the two links attached to the ground in this case, which is the shortest link, will be able to perform complete rotation. Okay, and if also the coupler which is doing a general plane motion also will be able to do complete rotation. So this mechanism will allow me to have two cranks in my system, and even the coupler is doing full rotation. Okay, but the coupler, I remind you that the coupler has general plane motion, so it can rotate and translate, but it can, whenever